Welcome to an online module of FOR 375 Introduction to Geospatial Analysis. In this brief module, we will talk about the US Public Land Survey System. Let's start from the beginning. In colonial times, the original colonies adopted the traditional English system to delimit parcels of land. It's the meets and bounds system where parcels of land and properties are delimited by describing their boundaries using physical features of the terrain and physical markers. What we have here is a historical record of a piece of land that was first surveyed in 1808 and resurveyed in 1897 in Tennessee. This is the full record. It gives you the total area of the parcel and a detailed account of how to find it and how to delimit it. Look at what the boundaries are. We have trees, we have riverbeds, and distances from said markers. This is a system that evolved over time and worked fairly well in a densely populated country like England, where property boundaries have been well identified, recorded, and slowly evolved over the course of centuries. It might not work as well in a country that is rapidly expanding westwards, like the United States. The tracts in the meets and bounds system are very irregular. They depend on markers that might or might not be permanent, might or might be not easy to identify uniquely. And as time passes, this is a system that might cause trouble, may cause boundary disputes. It's hard to know which one is the oak that was there in 1808 if we go there 100 years later. So in 1784, US adopted what was a highly scientific and objective system for the times, a rectangular survey system that is adopted at the moment in 30 of the 50 states. It's mostly used in all the states that were not fully established at the time of the adoption of the new survey system. This system identifies land using a square grid of property boundaries that starts from a central meridian and a baseline that changes state by state. There are 34 principal meridians in the United States. Each one has a baseline. Let's look at it. In colors, we have all the states that adopt the PLS system. In white is all the states that have older systems that predate the adoption of the square grid. You see here that the boundaries roughly follow the states, but not always. And once again, think of this as the system to assign property rights as the white settlement proceeded from east to west. So in many cases, the establishment of a central meridian and a baseline predates the establishment of what are now the states. Some of the boundaries are still there, but some are not. And let's look at our neighbors. Washington and Oregon have the same grid. Nevada and most of California have the same grid, but Southern California has a different one, and pieces of Northern California have their own. Montana has its own, but Wyoming, Colorado, Kansas, and Nebraska have a single one, and so on and so on. Just think of this as a system that has a long historic heritage. It's not something that we would design now, but it did serve its purpose at the time. In most of the West, though, property boundaries still follow this grid as it was initially settled. You can look at some at satellite images of Idaho, and you will see checkered patterns of logging that clearly still follow a square pattern, and they correspond to different ownership of the forest. Let's see how we can identify a parcel of land with the PLS system. We start with the baseline and the meridian. In the case of Idaho, it's the Boise meridian and the baseline that crosses Boise. It's a parallel that crosses Boise. The first subdivision, the biggest one, is a 6 by 6 mile square grid that define the so-called townships. One township is 36 square miles. We start from the baseline and the meridian to identify the relative position of the township. Let's focus on one. Let's focus on the one with the red circle. This township is 2 squares down from the baseline and 3 squares west from the meridian. So using the standard terminology of the PLS system, this is identified as T2S R3W, Township 2 South, Row 3 West. 36 square miles is a big piece of land, so we need to subdivide it. First subdivision is a 1 mile by 1 mile grid that defines 36 sections in each township. Each 1 square mile section is 640 acres, is numbered starting from the upper right corner of the township, then moving west until we reach the end of the township, then south 1 mile, then east, then down, then west, then down, then east, and so on. This might not be the first system you come up with if you had to number the sections of a township, but it's actually very logical if you think that field crews or surveyors had to physically walk the whole township and produce a map. So this system provides you with the opportunity of covering the sections in progressive order without ever having to go back and walk extra unnecessary miles. Let's look at one. How do we identify it now? Now we identify it as the number of the section attached to the number of the township the section belongs to. Here we're still at 1 square mile, so still a lot of land. If we want to buy or sell less than 640 acres, we need to subdivide the section. We do that using quarters of a section. We will have a northeast, northwest, southeast, and southwest quarter of the section, and then we can have quarters of a quarter of a section. Let's look at one on this case. This is the southeast quarter of the northwest quarter of section 14. Now let's put everything together. This piece of land, that is a 1/8 of the 640 acres of the section, is now called the southeast 1/4 of the northwest 1/4 of section 14, township 2S, row 3W. Once again, land in the west is still basically bought and sold according to the township section and relative fraction grid. Let's go back to the USGS map. This is once again a piece of the USGS map of Moscow Mountain. The red numbers are the numbers of the sections of the townships covering Moscow Mountain. So at the center we have sections 32, 33, 34. The red lines identify the section boundaries, is the section lines. And when we have a red cross at the corner, it means that there's a monument, so there is a physical marker to delimit the corner of the section. In this case, provided that the map is updated and nobody has altered or moved or destroyed the monument, if you walk to that particular point, you will find a physical marker. I want to conclude this online module with a vintage photo of the Crow surveyors in southern Idaho in 1919. It's an old photo, but not that old. It's only 98 years old, basically the time of our great-grandparents. This was a tough job that required bushwhacking for miles and spending weeks and weeks in uncharted areas with analog instruments trying to make the most accurate map possible. Piece of trivia: the reason why we have localities like Harvard, Princeton, and Yale north of Moscow is that some of the survey crews were students doing that during their summer breaks, and so they decided to name previously unnamed localities using names of colleges. If you want to know more about the history of surveying in the United States, there is a very comprehensive book available as a free PDF from the Bureau of Land Management, the BLM, that you can find at this link. Thank you for your attention.